Yes.
Hello viewers, we are going to look at resolution of forces. We've been given this question. These are concurrent forces acting at the same point. And in this question we are to resolve these forces. We have to determine the resultant. There's a determine let's say I resultant of the forces and II the angle theta. Okay, we can call the angle theta. So whenever we are given forces, concurrent forces acting, at the same point, there are a lot of there are different approaches. There are different approaches to this question, but I'm going to use the type that is very simplified, that makes the whole thing easy. That is going to make the whole thing easy for us. So for this method, this is the positive side of x, and this is the negative side of x. This is the positive side of y and the negative side of y. So for this method, we are going to be taking our forces, are going to be taking our angles from the positive side of x to wherever the force is. For each of the forces, we take our angles from the positive side of x to wherever the force is for each of the forces, and that's the angle we are going to be using to solve the question. So for this first force, F1, the angle is from this positive side of x down here. Let me do it this way, from here down here, and it's 30 degrees. Okay, so that is for force F1. Now for force F2, we are going to take the angle from the positive side of x, which is here, to where the force is. So we take it, I want to take it and use a new pen, so that a new marker, so that we see what is happening. So we take it from the positive side of x to where F2 is. And so let's find out what the angle is. From here to here is 90 degrees. That's from here to here is 90 degrees. And we know that we've been told that from here to here is 20. So 90 plus 20 will give us 110 degrees. So from here down here is 110 degrees. So for force F3, we have to take the angle again from the positive side of x down to where the force is. So we take the angle like this down to where force 3 is. So let's calculate the angle now. This is 90, from here to here is 90. This is another 90, making it 180 degrees. And plus this other 90, so we have 180 plus 90. This gives us 270 degrees for force F3. Now for the last force, which is force F4, we still take the angle from the positive side of x down to where the force acts. So we take this down to where the force acts. Okay, so it is here, and so we know that here is 90 degrees, here is 180, here is 270 degrees. Now we've been told that from here to here is 15 degrees. What it implies is, if from here to here is 15, and from here, and this is 90 degrees, and from here to here is 15, it means the remainder here is what? 75 degrees. That is, this is the, all of this is 90, and we've taken out 15, so it will be 90 minus 15. That will give us 75 degrees. So we are going to add that 75 degrees to 270. That is, it means from here to here now will be 75 degrees. Then we add it to the all of from here down. So when we say 75 plus 270, that will give us 345 degrees. So the angle from the positive side of x down to where force F4 is 300 and okay, let's use here, is this okay, we can say 345 degree. We can put it there. So having done this, we can now take the angles and the forces. so that we can, begin our calculation. So from here we can say that theta 1 is 30 degrees. This is theta 1, which is 30 degrees. And F1 is what? F1 is, F1 is 150 Newton. So our theta 2, this is theta 2, let's call this is theta 1. This is theta 2 equal to, this one is theta 3 equal to, this one is theta 4 equal to. So our theta 2 is 110 degrees, and then our F2 is 80 Newton. So our theta 3, this is theta 3, is 270 degrees, and our F3 is 110 Newton. And then our theta 4 is 345 degrees, and F4 is 100 Newton. So we've been able to take out the values of theta. Remember how we determine this theta. You take it from the positive side of x to wherever the force acts, and then you calculate the angle. So having gotten this, we can say that let Fy be a vertical force, and Fx be a horizontal force. So we've been able to establish that Fy is a vertical force, and then Fx is a horizontal force. What this means is, if we have this diagram, okay, this is vertical, so this will be Fy, and this is horizontal, this will be our Fx. So having established this, we can now resolve our forces vertically and horizontally. So we know that when we are resolving forces horizontally, it will be cos. We use cos when we are resolving forces horizontally, and when we are resolving forces vertically, we use sine. So let's take resolving. Okay, I think I can now make use of my black marker. So let me take this, make use of this. So we say resolving forces horizontally. So if we are resolving our forces horizontally, remember I said when you are resolving forces horizontally, you use cos. Okay, so we are going to say if x equal to, so we are going to take each of these angles. So the force and the angle, the force and the angle, the force and the angle, the force and the angle. So the first force is 150 Newton, so it's going to be cos theta 1, which is 30 degrees, plus the second force is 80 Newton, and the theta is cos 110 degree, and then the third force is 110 Newton, and our cos is cos 270 degree, plus, and the last force is 100 Newton, and the angle is cos 345 degree. So we've been able to resolve forces horizontally. So what is cos? If you punch your calculator, you discover that cos 30 is 0.866. So when you multiply it by 150, that is going to, when you multiply cos 30. So you find cos, you punch your calculator to have cos 30, you multiply it by 150, that will give you 129.9. And so the same thing, you find cos 110, which is going to give you minus 0.342. And so when you multiply it by 80, you're going to have minus 27.4. And so you continue, you find cos. If you find cos 270 is going to give you 0. So when you multiply 0 by 110, you have plus 0. And then when you find cos 345, it's going to give you 0.965. And when you multiply it by 100, you have plus 96.6. And so when you solve this, 129.9 minus 24.4 plus 0 is out, 96.6. That will give you your fx to be equal to 191.1. So this is what we have as a horizontal force. So once we resolve this horizontally, this is what we have as our answer. And so we can now resolve the forces vertically. Can we still use here? Yes, sure. So resolving forces vertically. So when we are resolving forces vertically, we use what? Sine. And so this is going to give us Fy equal to, alright, we take the first force 150 multiplied by theta 1, which is sine 30 degrees, plus the second force 80 multiplied by theta 2, which is sine 110 degree. The third force 110 Newton multiplied by theta 3, which is 270 degree, plus the last force 100 Newton multiplied by theta 4, which is sine 345. Okay, this should be in Newton. This is in Newton. So once we resolve this, okay, let me do let's solve it here. So when we find sine 30 is going to give us 0.5, and when we multiply it by 150, we'll have 75. And then if you punch your calculator to find sine 110, that will give you 0.939. And so when you multiply it by 80, it will give you plus 75.2. Okay, let me write it properly. Or 75.2. And then when you use your calculator, I didn't do this correctly. This is sine 270 degrees. Okay, so when you find sine 270, it's going to give you minus 1. And so when you multiply it with what are we doing? Okay, F2 is 80. Okay, F3, the force is 110 sine. Okay, we are correct. Okay, so yeah, we are correct. So when you multiply it by 110, it will give you, because it's minus 1, so minus 110. And then when you punch your calculator to determine what sine 345 is, it will give you minus 0.258. So when you multiply it by 100, it will give you minus 25.9. And so when you solve this, when you use your calculator, so say 75 plus 75.2 minus this, your answer, your Fy, is going to be 14.3 Newton. So in this, we've been able to resolve the forces horizontally to have this value, and also we've been able to resolve the forces vertically also to have this value. So at this point, we can now find the resultant of the forces, and when we are done determining the resultant of the forces, we can now determine the angle of the forces. So now what we want to look at is to determine the resultant of the forces. So our first question was to determine the resultant of the forces. So to determine the resultant of the forces. So in order to determine the resultant of the forces, we know that this, okay, let's draw this diagram. This is our y and this is our x. So which means whatever we have in y, we write it out. Y is 14.3 Newton, and so our x is 199.1 Newton. And so this is the resultant. And so to determine the resultant, since these forces are acting at right angle at this point, we apply the Pythagorean's theorem. I've done it in the other video, so you can watch the video where I actually find the resultant of two forces acting at right angle to each other. So for us to determine a resultant here, R will be equal to square root of this force Fy squared plus Fx squared. So this will be Fy squared is 14.3 all squared plus 199.1 all squared. And so when you determine the square root of this, so we are going to have this to be, square root of this will give us 39, okay, square root of this will give us 204.5 plus square root of this will give us 3964 0.81. And so when you add this to this, we are going to have a resultant to be equal to 3984. When you punch your calculator, you are going to have these values and 31. And so when you find the square root of this, it will give you 199.6 Newton. So what this implies is that the resultant of these two forces will be 199.6 Newton. So our second question was to determine the angle. Second question was to determine the angle. So II to determine the angle theta. So let's call the angle theta. So if we are to determine the angle theta, we use tan. So it will be tan theta will be equal to whatever we have as resolution of Fy, that is vertical forces, divided by horizontal forces. So this will be Fy over Fx. And so for us to determine theta, theta will be tan inverse. Tan inverse. So okay, let me break it down for some of you who do not understand how we got about the tan inverse. So since we are looking for theta, okay, since we are looking for theta, we divide both sides by what? Tan. So, or you can say, if you don't want to say divide both sides by tan, since we are looking for theta, we can say multiply both sides of the equation by 1 over tan. So let's use that one. Multiply both sides of the equation by 1 over tan. So the essence of doing this is to ensure that we eliminate tan here, since we are looking for theta. So It's more or less saying making theta subject of the formula. So if we implement this, we are going to have 1 over tan multiplied by tan theta equal to 1 over tan multiplied by Fy over Fx. So from here you can cancel out, and so that your theta will be equal to 1 over tan dot Fy over Fx. Note the dot is the same thing as saying multiplication. Dot is the same thing as saying multiplication. So from our indices, we know that from indices that 1 over a is a raised to power minus 1. So we apply the same thing there, so that 1 over tan will be tan inverse of 1. So we have theta equal to tan inverse of Fy over, okay, tan inverse of Fy over Fx, so which is equal to tan inverse of, what is our Fy? Fy is 14.3 divided by Fx is 199.1. And so when you divide this by this, you are going to have that theta will be tan inverse of 0.0718. And so when you punch your calculator, when you punch tan, for those of you who don't understand how to get tan inverse, if you have a calculator that has second function, you punch on and second function, and then you click on tan, it will give you tan inverse. So when you find the tan inverse of this, your theta will be 4.12 degree. So what this implies is we've been able to determine the resultant of the forces to be 199.6 Newton, and then the angle is 4.12 degrees. So basically this is how to resolve forces, take resolution of forces to determine the resultant and the angle.